Hello and welcome to another episode of Slam TV. I'm Professor Roger Yang, and today we're going to learn about tests for the proportion. Luckily for you folks at home, we've got a very special guest for you. He's the top unpaid intern at HTI Pasadena. He works hard for the money.
Dun, 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 dun.
So hard, funny honey.
Dun, 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 dun.
He works hard for the money.
So you better treat me right.
That's right. Hey Jay, how's it going?
Pretty good. Just finishing up my semester for HTI, Hypothesis Test Investigator training program.
That's awesome. Congratulations.
Yep, super excited. And I did something I'm really proud of too.
Oh, really? What's that?
I just booked an appointment with a counselor to create a CSEP, which is an ed plan.
Doesn't CSEP stand for Complete Student Education Plan?
Yes, it is. It's a plan that helps you figure out what classes you need to take to complete your academic goals.
It'll also tell you how long it takes for you to graduate and or transfer to a CSU or UC. So if you don't have an ed plan already, book an appointment with your counselor so that you can get one soon.
I think I'm exceptionally special student because I'm getting my CSEP done.
Really? Is that so special? I thought that the majority of students go to see their counselor to get an ed plan.
What? Are you saying I'm not exceptionally special student?
Jay, you're so special. But I'm pretty sure the majority of students go to visit a counselor to make an ed plan.
Oh, doubt it.
If only there was a way that, some statistical technique we could use to test the claim that majority of students go to see the counselor to make an ed plan.
Actually there is.
There is?
Yeah, we can test claim about proportion.
Is that similar to testing a hypothesis test for a mean?
Yeah, the process is pretty similar. There are some details we have to kind of change. Let's first start with writing down our claim.
Majority of first-year college students have visited a counselor to create an ed plan.
What do you think is claim about a proportion?
Well, it seems like it's categorical data. Either you've gone to a counselor to make an ed plan or you haven't.
Exactly, it's categorical data, not quantitative data. You're not measuring any amount or anything. In a claim, it says majority of students. What do you think majority means?
Well, majority means greater than 50% of the people in your population or sample.
So how do you translate this majority into mathematical statement?
Well, this is about proportion, so I think we'd start off writing the population parameter p. So our claim is going to translate to p is greater than 0.50.
Correct. Would this mathematical statement be null or alternative hypothesis?
Well, because the statement has a greater than symbol, I think that this particular statement corresponds to the alternative hypothesis.
And what would be the null hypothesis?
Well, the null hypothesis has to be set up to be the direct opposite of the alternative hypothesis. So the null hypothesis H naught should be p less than or equal to 0.50.
Okay, don't forget to label the original claim. Which one would that be?
Oh yeah, the original claim is going to be our alternative hypothesis HA.
Excellent. So what's our random variable here?
A random variable will be x bar, right?
X bar. Why x bar?
Well, all the previous hypothesis test examples we did, the random variable was x bar.
Well, on our previous examples, we are estimating mean.
You mean hypothesis test for the mean?
Yes. So that's why we need the sample mean to see how unlikely it is compared to all possible sample means. That's why we're using x bar.
Oh.
Here, we are not dealing with the mean, but we are dealing with...
Oh, we're dealing with sample proportions, p hat.
That's why we need p hat. And also our distribution will be...
Well, you said before we were looking at the distribution of sample means and seeing if our particular sample mean was unusual. Now it seems like we should look at the distribution of sample proportions?
Exactly, that's what we need here.
So what is that?
Well, remember back when we were testing if people are washing their hands, we were testing for population proportion, confidence
we were trying to
interval.
estimate that.
Yes, remember?
Oh, yeah. I can't believe such a large percentage of people don't wash their hands after using the restroom. I mean, I don't even shake people's hands anymore.
I know. High five.
No.
Anyway, do you also remember that we use normal distribution to approximate binomial distribution?
Oh yeah, we needed NP to be bigger than 5 and NQ to be bigger than 5, right?
Yes, except that some books will say NP is bigger than equal to 5 and NQ is also bigger than equal to 5. Yeah,
So which one should we use?
Well, let's just make sure that we have enough sample. So let's just keep it that NP and NQ are both bigger than 5.
Can you remind our viewers of what P means again?
Well, P is probably a success. In our case, making an appointment, going to see a counselor to create the ed plan is a success. We'll assume that P is equal to 0.5 from the null hypothesis.
Oh, okay. Then Q, the probability of failure, will be 1 minus P. In our case, Q is equal to 1 minus 0.50, which is equal to 0.50. Okay, cool. Let's go sample some people. Man, collecting data is exhausting.
That was tough. At least we have our sample data. So what are the results of the sample?
Well, we sampled 36 people
Okay.
and we ended up getting 23 successes.
Okay.
So if we were to look at NP, N was 36 and P was 0.50. 36 times 0.50 is equal to 18.
Which is bigger than 5. Great. And also NQ, 36 times 0.5 is 18, which is also bigger than 5.
Oh, that's awesome. That means we can use the normal distribution to approximate the binomial.
Exactly. So far we got our random variable p hat. I got distribution is normal. Remember there are two important numbers for normal distribution?
Oh yeah, the two important numbers for a normal distribution are mean and standard deviation. What's the mean for this distribution, Jay?
Well, mean for distribution here is at the middle of the distribution. It comes from H0, which is the null hypothesis.
So our null hypothesis was P less than or equal to 0.50. This makes the center of our distribution 0.50, right?
Exactly.
So what's the standard deviation for our distribution of sample proportions?
In this case, we're going to use standard error for proportion to get that number.
Can you remind us what the formula for that was, Jay?
Sure. That's square root of P times Q over N.
Okay, let's plug our numbers in to get the standard error for the proportion. We know that P is equal to 0.50, so we plug that in. We know that Q is equal to 0.50, so we plug that in. And we have N is equal to 36, so we put that in last. Next, we need to find the p-value, right?
Exactly, Roger. I'm going to use this prop calculator and use one prop z-test calculator function and alternative hypothesis to figure out how unlikely our sample is.
Okay, so we have our one prop z-test calculator function here. The first line is p naught, and we basically need to tell the calculator what the null hypothesis is. So we're going to enter in 0.50.
Right, next two lines comes from our sample. X is the number of successes. We had 23 people said they made an appointment with the counselor. And N is sample size, which was 36.
The next line corresponds to the alternative hypothesis. In this case, this is a test for proportion, and our alternative hypothesis was it was greater than the null hypothesis, p naught.
Right, and the last line it says calculate, and that's what we need to punch in to get our result.
Does it seem like we entered everything correctly?
I think so, yeah.
Oh. You seem excited.
Not that much.
Oh. Okay. All right, let's take a look at these results. So it looks like the first line is just our alternative hypothesis.
Right, and the second line it says z is equal to 1.6667. That's the z-score we get from our normal distribution.
Oh, that's the test statistic.
Exactly.
I see the next line is the p-value. P is equal to 0.4779, blah, blah, blah.
Right, so basically 0.048. And the next line it says p hat. Oh, that must be our sample proportion.
And finally, they end up with the sample size, which is 36. We got a p-value of 0.048. What was our significance level again?
The significance level of alpha is 0.05 because they didn't say any otherwise.
Oh, okay. Let's use these two to make a decision. Since our p-value of 0.048 was less than our significance level 0.05, our decision is we reject H0. Okay, Jay, help us tie this decision back to our original claim.
Well, our original claim was the alternative hypothesis, HA. So alternative hypothesis, HA, is p bigger than 0.50, which is the original claim. So our conclusion will either be support or fail to support the original claim.
But since we rejected H0 and HA and H0 are opposites,
that means we support the original claim.
Therefore, our conclusion is the sample data supports the claim that the majority of college students have visited a counselor to create an ed plan. Oh, so this means the majority of students do go to see a counselor to make an ed plan.
Oh, that means I'm not exceptionally special, huh?
Oh, no, that's not true, Jay. You're still special, but you're not special just for going to see a counselor to make an ed plan. That makes you a responsible and intelligent student.
Oh, wow. So you're saying I'm special, responsible, and intelligent. Wow. If you want to be special, responsible, and intelligent like me, please go see a counselor, make an appointment, and create your ed plan.
Ed plan.
Ed plan.